All right, in this little series of videos, we're going to be solving radical equations. And I've put up there 5 different steps that I go through personally in order to solve these things. One that I didn't put up there is sometimes you can just kind of think your way past them. The example here that I have listed is the very first one. I have the square root of, well, in this case it looks like x minus 5, but I'm just going to generically say the square root of something. What does that something look like? It looks like that. Okay, so the square root of something is -1. So I go through what I know. Let's see this. If I take the square root of a positive number, it's positive. But if I take the square root of 0, it's 0. And if I take the square root of a negative number, well, if you already happen to have had the introduction to imaginary numbers, you know that the square root of -1 is I. If you haven't, let it go. At this point, it's just not doable. Well, so now we've exhausted positive numbers, the negative numbers, and 0. That's it. There are no other kinds of numbers that we're aware of at this point. So we've checked all the numbers. This can't happen. The end. So, no solution. That's it. So now, see, we didn't even have to go through the 5 steps. We're fine. All right, so let's go ahead and do this. This second one here, it does actually have a solution. So we're going to go through it and check it. Step 1 says isolate one of the radicals. Well, look at that. There is only one, and so it's isolated. It has nothing around it. There's no coefficient. There's nothing adding or subtracting to it. It's not being raised to a power. We have nothing else to do with it. It's done. So we did it. Next thing, raise both sides to the exponent matching the index on the isolated radical. This is the important part. Only on the isolated. If there's others, don't worry about them. Leave them till the end. So the index, if you recall, is this number that sits right in there, and if it's not there, it's a 2. So this is the square root of x minus 5. So when we do this, we're going to raise both sides to the square. That's it. That starts the whole mess. All right, the idea here is that it's a function. Since taking the square of a thing is a function, whatever a single input is has exactly one output, so we can guarantee that these 2 outputs must be the same by definition of a function. So now we come up into step 3. We're going to clean up, so we have to do the thing. So when we do the thing, the square of a square root, these 2 things are effectively opposites, if you want to think of it this way. They are inverse functions of one another. They cancel each other out. We're left with x minus 5. On the other side, we would have to square this side. And so this is going to be 1 squared to give us 1. In the third step here, clean up by combining like terms. All right, this is if you have a little bit more complicated one. You might have some stuff left over. And here's where you might have other roots left over that you have to deal with. Now you re-isolate them and go back and rehash steps 1 and 2 until they're complete. Now, step 4. Once all the radicals have been canceled, then you can solve appropriately. By appropriately, it means sometimes you might end up with something like this. Sometimes it might be a little more complicated. So I kind of just have that in there as a general look. I don't know what yours is going to look like. And we'll see. Not all of them look the same. I'm going to go ahead, I'm going to add 5 to both sides. And I get x is equal to 6. Okay, this is the step nobody likes. Nobody wants to go back and do this step. Do the step. Because as we will see later in these videos, you could end up with something that, well, quite frankly, ends up not true. We'll see. All right, so what I'm going to do then is I'm going to rewrite this, and wherever I see an x, I'm going to drop a 6 in its place, just to check. And so I'm checking, is this true? Well, 6 minus 5 is 1. Square root of 1 is in fact 1, so yeah, it's true. This is a good answer. So that's the answer, is x equals 6. The end. Wash, rinse, repeat 47 billion times. Seriously, that's all it is. So I'm going to try to match the colors to the different steps, but if I forget one, please excuse me. So this next one here looks a little bit more complicated. But we have to go to that very first step, and that very first step, which is in light blue, I believe, that very first step says isolate the variable, or isolate the radical. When you do this, anything that's around it needs to be done. You're effectively making this chunk look like y. So you have like y minus 7 is equal to negative 3. How would you solve for y? Well, this is also the spot where you might say, well, look, we've got a square root and it's equal to a negative number. It doesn't work like that, because if you isolate the radical, you notice that it's actually going to be positive, so we do have a chance. So if you do that, you notice that you got to give everything away from the y. We're going to use that idea here. I'm going to add 7 to both sides, and what this is going to do is this is going to isolate my radical. So I have the square root of 3x plus 2 is now going to be equal to positive 4. From here, I work it the exact same way that I just did this last one. So I'm going to square both sides because that matches the index over here. And when I say both sides, I really do mean both sides of the equation. And then I'm just going to solve it out. So now I've got this square and this root canceling, leaving me with 3x plus 2 is equal to 16. Now just solve it just like you would any other linear equation. You're going to subtract 2 from both sides, and that gives me 3x is equal to 14. And I divide by 3 on both sides, and x is equal to 14/3. That's it. And you say, oh, okay, well, that's not so bad, right? And that's the answer. Or is it? Remember that last step nobody wants to do? Do it, because you never know when it's going to turn out to be not true. And so we take our square root, and we have 3 times 14/3 plus 2, and then the minus 7 goes on the backside, equals negative 3. I always do this, by the way. Always. I never go back to any of the other steps and substitute in. I always go back to the very original step, because it gives you the best chance. Well, 3 times 14/3, the 3's cancel. That leaves me with 14 plus 2. So I have the square root of 16 minus 7 is equal to negative 3. But the square root of 16 is in fact 4 minus 7. Is that equal to negative 3? Yep. So we're good. 14/3 checks out. We're done. The end. Go ahead and take a look at the next video in the series. Conquer some other ones in that one.